In this class, we're going to take a look at the graphs of the sine and the cosine function. So when you come across sine and cosine for the first time, it's normally in the context of SOHCAHTOA, which is the trigonometric ratios. And SOHCAHTOA has got to do with right angle triangle. So this works by constructing a right angle triangle, and we label one of the angles as our sort of reference angle, so maybe this angle down here, and then we say that the side opposite that we call, well, opposite, O for opposite, and then adjacent, and then the hypotenuse, and then that's what we use as the basis for our definition. So for example, the sine of the angle x is opposite over hypotenuse, and the cosine of the angle x is adjacent over hypotenuse. And that's probably the first time that we see sine and cosine. But when you get further into trigonometry, you want to consider sine and cosine kind of no longer to do with right angle triangles. You want to study them as functions in and of themselves. So for example, if you take your calculator, which is how you generally process these when you first meet them, and you do the sine of some number, so the sine of 30 degrees, the calculator gives you back an answer. We want to start to think about, how does that work? Where does that answer come from? How can we understand the sine and cosine process a little better? And one of the ways we can do that is just by studying the graphs of these functions. We can study the tan graph as well, but it's a little more complicated, and we're not going to look at that in this class today. But let's think about the graphs of sine and cosine and what restrictions or just criteria we can learn from the graph that help us to understand how they work. So we'll start with the sine function. So we're going to look at the graph of y equals sine x. So the way that these work is, if you've never seen these before, they'll be a little strange at first, but the way that they work is by presenting the x values, the values on the horizontal axis, as the angles kind of in a circle. So we consider one cycle of the graph to take 360 degrees. I'm just going to draw the graph in red. The graph itself is kind of this wavy thing. It goes like that. And it's got key points every 90 degrees up to a total of 360. So that point there is at 360. This middle point is at 180. This point here corresponding to the highest point on the graph is at 90. I should really put degrees on these because all the trig functions, sine, cos and tan, work in degrees. And then this point here, which corresponds to the minimum part on the graph, is 270 degrees. This highest value, the highest value the graph gets to on the y-axis, is at 1, and this lowest point here is at -1. Although we only draw the graph like that one cycle, it does actually continue on backwards forever. I mean, this graph carries on forever this way, and it carries on forever going forwards. But we call that one cycle of the graph, and you could carry on the graph going that way as well. So it's not the entire graph. That's important to know. That's just one. It's just the part that we want to look at, but the graph carries on forever that way and forever this way. So a couple of things to just notice from this graph that start to pop out as important for the sine function. It never goes above 1 and it never goes below -1. So the way we would say that is that the maximum value, so the maximum value, which is just the highest point on the graph, the highest y value, so the maximum value is 1. That's for a normal sine graph. And the minimum value is -1. So that means that if you take your calculator and you do the sine of some angle, then you cannot get a value that's greater than 1 or -1. If somehow that happens, then something's gone weird in the calculation, or your calculator is broken or something like that. But it shouldn't be above 1 or below -1. Also, the graph takes one full cycle in 360 degrees. So we call that the period. So we say that the period of the sine graph is 360 degrees. The maximum height, the height that it goes up to, and the kind of size down the way as well, so this like up and down value, we call that the amplitude. And the amplitude of a sine graph is 1. One of the things though that you start to do in trigonometry, once you've learnt these graphs, is to manipulate them in some way. So sometimes we stretch this graph up and down the way, which would affect the amplitude. Sometimes we squish the graph, and that affects the period. Stretching it would also affect the max and the min value, or moving it up and down would affect the max and the min value. Those are called graph transformations, and they come further down the line. I chat about those in the course. They're important actually in trigonometry, but this is really your starting point, just to learn about this basic sine graph. So those are some of the key points. So what do we actually mean about using the sine function and thinking about it in terms of the graph? Well, let's say, for example, we took a point here, which is at, well, let's take 30. So if we take a point at 30 degrees, if you take this point here at 30 and you go up to the graph, so go up until you hit the curve, and then go along the way, whatever value you get here, this up and down value, the one that's between 0 and 1, that is the value your calculator would give you. So if you did this calculation here, and you chose to put 30 degrees into the calculator, then whatever value that gives you is that value there. And it turns out this one is 1/2, so which is looking pretty good on the graph because that's right between 0 and 1. So the sine of 30 would give you 1/2 or 0.5 from the calculator, and it's doing that by reference to, or not really by reference to, but that's how you would visualize that on the graph. So just by knowing how the sine graph works already starts to give you insight into the numbers that we just kind of blindly get from the calculator. So that's the sine function. The cosine function is kind of paired up with the sine function in the sense that they're the same graph, just shifted over. So if you shift the y-axis to there and then start from that point, that is the cosine function. Every other feature is the same. So the cosine function just starts up there and it has one cycle that goes like that. So it's effectively just that part of the graph. So again, maximum value of 1, minimum value of -1, 360 degrees for one cycle. So all of the key points again occur every 90 degrees. So this point here is at 90 degrees. This middle point corresponds to 180 degrees, 270, and then the very end point is at 360 degrees. So just identical to this graph, just shifted over a little. So all of these values here, everything that we can say there for the sine graph, we can also say is true for the cosine graph. And again, we would be looking to manipulate this graph. We'd maybe put a number here, and those have an effect of stretching the graph, moving the graph, doing some manipulation to the graph called a graph transformation. And those are really important in trigonometry. We study those a lot in the course of learning more trigonometry. So the key takeaways are that the sine and the cosine function are bounded above, in other words, maximum value of 1, bounded below, minimum value of -1. Their graphs recur every 360 degrees, so that's said to be the period, and they've got this amplitude value, this like up and down value of 1, and they're the same graph, just shifted over a little. The tan graph, on the other hand, is a completely different thing altogether. It looks nothing like these guys, it's unrelated. It's a fiddly graph, it's got some kind of holes in the graph, it's a little bit messed up. So we tend to learn sine and cosine first, and then later on look at the tan graph. We're not going to look at that in this class, and we're also not going to look at any transformations, but that's because this is your starting point. This is enough to get going with. Practice drawing these graphs are really important if you're taking a trigonometry course. Learn these maximum values, these key values, including the maximum value, and think about how that relates to what you've probably seen before, which is SOHCAHTOA. You can even take some estimates off the graph. So you could, for example, say, right, this point here, which is maybe around 80 degrees. So let's say that's at 80 degrees. Then if you go up to the graph, hit there, and then go over, and take a guesstimate of what that might be. So then put that in the calculator. So go cosine of 80 in the calculator and see what that comes out to be. So it looks to me like that value is just a little bit below halfway. So it should be something smaller than 0.5. So practicing to draw the graphs and then checking them on a calculator, that's a great way to learn if you're drawing them correctly. And it just starts to give you a feel for how these functions work. So that's just basically a bit of an overview, an introduction to the sine and the cosine graph. Really important if you're studying trigonometry, and trigonometry stays with you throughout your whole math career. It's in pre-calculus, it's in calculus, it's just everywhere. You never get away from these trig functions. So the more quickly you can get down with these ideas and these graphs, the easier it's going to be in the long run.